All right, at the bottom of page 359, we have a table listing several cities, their latitude, they all happen to be in the northern hemisphere, and then their average annual temperature in Fahrenheit. First of all, your two variables are latitude and average annual temperature, okay? And you can take all of these ordered pairs and plot them on a graph, which is what they want you to do right here. Okay, so now this is page 360. What I want you to do is pause this, take a second and graph the points, and then see if you get what I get, and then we'll go from there. Okay, hopefully you got something that looked like this when you took all the data points from the previous page and plotted them. Now, in just a second, I will show you how to do the same thing, but on your graphing calculator. But obviously, I'm a big advocate of using your graphing calculator to just speed things up, not to do things that you don't understand how to do. So I do want you to be able to plot these by hand, but you can also learn how to do it on a calculator, and that just saves you some time, okay? Now, looking at those data points, I'm hoping that you guys can see that as the latitude goes up, generally speaking, temperature goes down. So this is a negative correlation. Okay, boom, we've magically changed to purple ink somehow. Anyway, the variables are negatively correlated, as I stated. And then it says, why are the points in a scatter plot not connected in the same way plots of linear equations are? And that's because the data in scatter plots represent discrete pieces of information, discrete points, okay? You may not have a range of points. Typically, you don't. You have pieces of data and you put it on a graph and you just keep it as points. Now, you'll notice, you're like, Ms. Goff, there's a line though on my graph. So this line is my best guess at the slope for this set of points. And you're going to learn that that line is called a line of best fit, okay? And there's actually a way on your calculator to figure out exactly what the equation of that line is, and I will also show you that. Okay, so there's some information at the bottom of page 360. We've actually discussed this already, sort of as an introduction. One way to quantify the correlation of a data set is with the correlation coefficient, which is denoted by the letter R. We've already talked about this some. Coefficients vary from -1 if it's a super strong negative correlation, all the way up to +1 if it's a really super strong positive correlation, okay? Weakly correlated data will have values closer to 0. Strongly correlated data will have values closer to 1 if it's positive, or -1 if it's a negative correlation, okay? Sort of so-so correlations will be, you know, somewhere in the ballpark of like a 0.5 or something like that, okay? All right. Can you calculate correlation coefficient? Yes, you can, but it is beyond the scope of this course, so of course we're not going to do it. We're just going to sort of estimate it. Okay, and this is page 361, this is basically a visual of what they've just talked about. Strong negative correlation, all your points are pretty close to some imaginary line, and so your correlation coefficient is going to be close to -1. Strong positive correlation, again, all of your points are going to be really close to some sort of imaginary line that you could draw through the data. And so your R value, your correlation coefficient, is close to +1. Weaker negative correlation, maybe an R is close to -0.5. Weaker positive correlation, maybe the R is close to +0.5. And again, if you had like no correlation at all, maybe something like this, then your correlation coefficient is basically 0, okay? Okay, example 1A says to estimate the R value for the relationship between city latitude and average temperature using the scatter plot. Okay, this is going back to page 360. And we talked about already that we thought that this was a negative correlation and that it was a pretty strong negative correlation. So I would say that it's probably not exactly -1 because there's some points that are a little off, but I would say that this is going to be a correlation coefficient close to -1 because it's a pretty strong negative correlation. Okay, then they give you this next example, winning versus losing scores. So losing score down here, winning score down here. I don't know, maybe they watched a bunch of football games and just plotted the winning score for the teams that won versus the losing score of the team that they played. Even though the data doesn't take up the whole entire graph, I'm looking at this and there's no real pattern that I see. I don't see kind of a positive trend. I don't really see a negative trend. So I'm going to say that the R value is close to 0 because I really don't think there's much of a correlation at all. Okay, I'm now on page 362 and it says your turn. So look at 2 and look at 3. Pause it for just a second if you need to think. And figure out what kind of correlation and how strong you think the correlation is for number 2 and number 3. For number 2, I think that it's a positive correlation, but I think it's a pretty weak positive correlation because there's a lot of scattering of those dots. They're not, all close to some central imaginary line that I could draw. On number 3, this is a negative correlation, and I could draw a line through here and they're all fairly close to that line. So I would say that this is a strong negative correlation. And again, I would say that this one is a weak positive correlation. Okay. Okay, so we're going to start talking about line of fit, line of best fit, ultimately. Right now, they're just going to call it a line of fit because they're asking you here to just kind of eyeball it and draw in what you think your best estimate of the slope of a line for that set of data points. So this is the same set of data points that they had you plot on page 360. It's just they kind of cropped the graph a little bit to zoom in on it, but it's the same information. Okay, and then they have drawn a line. Now, we're back to a concept that we've done over and over and over again, which is, can we figure out the equation to that line? And the answer obviously is yes. Okay, I can look very closely at that line and I am going to try to find some points along the line that I can use to calculate the slope of that line. Okay, so hop over to 363 and kind of follow along with what they're doing. Okay, so they looked at the line and they noticed that the points 10, 95 and 60, 40 appear to be on the line. Okay, so they used those 2 points to come up with a slope. Okay, you have done this. This is I don't know, back to a skill that we learned in like module 5. All right, so now I have the slope. Well, let's put in the slope for M. Let's put in one of the points for my X and Y value so that we can come up with B, which is the Y-intercept. Okay, so they decided, once they knew the slope, they went back and grabbed this point, and it's just as correct to do this other point, but they grabbed this point and put the X value in for X and the Y value in for Y, and they did some math and generated that the Y-intercept, B, was going to be 106. So now they have everything that they need to give an equation in slope-intercept form because they have the slope and now they have the Y-intercept. So Y equals mx plus b. Here is the formula or the equation for the line that they drew. That's the best estimate for that line for that set of data points. Okay. All right, so let's go to B. Okay, so your first step is to plot all your points. You've got altitude on the x-axis and boiling point on the y-axis. So hit pause and do that real quickly. All right, so here's what I got when I plotted those 5 data points, okay? So I have 2 data points that are basically at 210 degrees Fahrenheit, even though one of them is almost at 0 altitude and the other one's like at almost 600. What I'm going to do next is I'm going to take a ruler and I am going to make a guess and draw a line that I think represents the overall general trend. And, you know, the problem with just doing this, kind of eyeballing it, is that my line may not be sloped exactly like your line or whatever. There's a little bit of margin of error, which is why being able to do this on the calculator eventually is going to be really helpful. Okay, but let me go ahead and grab my ruler. Okay, so I'm going to draw my best estimate of my line. Something like that. Okay. All right, and then a line of fit may go through the points. Okay, well, I'm going to have to stop and kind of look and see where I can find some data points. I'm hoping for grid lines because that'll make my job a little bit easier. I'm going to use this one actually up here. That's 211 and 0. So 0 and 211. And where's another one? Oh, this one's pretty good. That's 5,500 and 202. And we're going to use that to generate our slope. Okay, so generating our slope, I come up with this. And this is going to be another reason why learning how to do this on the calculator in a little while is going to be lovely, because if you look at my slope, I'm dealing with ugly number, okay? And I don't really want to round this off too terribly much because that's just going to generate more error. So I'm dealing with yuck on my slope, and I am just going to try to keep that number on my calculator handy. I know that y'all are probably having a hard time seeing it, but here's what I'm going to do. I'm going to take that number, I'm going to multiply it by 0 because I'm going to use this point right here. 211. Well, that works out. So yucky number times 0 is just 0. And 0 plus b is going to be 211. So my y-intercept is basically 211. Okay, so the equation is y equals 0.00, what was that number? I am going to have to round it a little bit. 0.00, oh, and it's negative. 0016 36 plus 211. Okay, so I can generate the equation of that line. But, you know, real life is sometimes not quite as pretty. And so the numbers aren't quite as nice to look at. But anyway, we can do this, but shortly we're going to start learning how to just do this on a calculator. First of all, I'm not guesstimating my slope anymore if I use a calculator. And the calculator is actually doing the number crunching for me and basically giving me, hey, here's your slope and hey, here's your y-intercept so that you can generate that equation. So, okay, so I'm going to end this video here, and I think the next video is going to be basically going back through some of these examples, but then helping you figure out how to put that information in to the calculator and have the calculator generating these graphs and these lines of best fit for you.